Okay, welcome to the first lesson of the course, where we're going to start with some introduction and motivation to programming and to Python, and start learning the basics of the environment we're going to work with and of programming in Python. So let's start. And let's begin with motivation. Let's begin with motivation for programming. And let's ask the basic question, why do we even want or need to do programming? What is it good for? So here we give a short list of different reasons I at least think are good motivation to want to program. So first off, we want to do things faster and more efficiently and to automate things that we are, otherwise would have to do manually, which could be a real drudgery. So programming is a very efficient way to automate things, which is quite intuitive. And sometimes it's not just convenience, it's even necessity, because once we exceed a certain level of amount of data, say, which is not that high, then it's just no longer practical for humans to deal with such great amount of data. It will not work. We don't have the time or the capacity or the accuracy to do that, and we get bored way too quickly. So once we work with sufficient amount of data, we really need to just use programming. Now, of course, you can say, okay, we need to have some computer software doing something for us, but why do we have to be the ones that write the software? Why can't we, just use an off-the-shelf tool? And the reason is that very often, especially if we do research and we want to do all kind of, things which have never been done, what is quite essential to cutting-edge research, then those off-the-shelf tools will never be as flexible as we need them to. They will always have some missing feature or something that they just cannot do, and there will just be no way around it. We will have to write our own analysis, and we can't be allowed, we cannot afford ourselves to be limited by what others just give us. So we will have to make our own analysis by just writing our code, and that is a great way for independence. And I think it's really liberating and very empowering to know how to program, because very quickly you realize that actually you can do pretty much everything you want when it comes to analyzing data. You're just not limited by anything that was conceived or thought of before. You just do it on your own. And finally, I hope that you will come to appreciate throughout this course what many programmers rather soon start to appreciate is that programming can be a lot of fun. It can be really nice to just write a piece of code and see it do amazing things. And yeah, I hope that at least that is something you're going to be persuaded of during this course. And there is this very nice quote that I like, sometimes falsely attributed to Albert Einstein. It says, "The computer is incredibly fast, accurate, and stupid. Man is incredibly slow, inaccurate, and brilliant, and the marriage of the two is a force beyond calculation." Okay, so that's going to be our mission here. We're going to marry the two. We're going to marry a great biological researcher with very efficient programming tools, and we're going to see how far it can take us. Okay, so we saw that programming is nice, but why specifically Python? Why not, another programming language? So there are many reasons that I personally really favor Python, and I think it's a really awesome language. So some very nice things about the Python language is, first, it's very, very simple and elegant. So I don't know of any other language which is so short and so concise and so to the point, where you just write what you want the program to do, and it just does it, without needing to write all of those chunks of code that don't really do anything, but you are forced to write them because it's supposed to be structured in a certain way. So it's very short and very elegant, and very easy to read. So here on the right hand side, I give you a simple example. So let's say you have some programming language like Java, which is also quite popular. In this language, just to write hello world, you see that you need to write all of those pieces of code, which for a basic programmer are not really clear why you need them. Whereas in Python, if you just want to print hello world to the screen, that's exactly what you write. You write print hello world and nothing more. And that's really a typical example, which illustrates, I think, pretty much everything you want to do in Python. So it's never the case that you need to write some pieces of code which are not really necessary. Other nice aspects of the language is that it's a dynamic language. Okay, now I'm not going to explain right now what exactly it means. It's something which we're going to understand more deeply as we progress through the course, and we'll understand what it means to be a dynamic language and how it's different from a static language. But I would only say that, again, it gives you a lot of flexibility and allows you to write code which is more simple and often more clear to human beings. Another nice aspect, again, I'm going to throw out of these concepts, which we're going to dive very deeply throughout this course, but not right now. There is usually this distinction between programming languages which are considered to be object-oriented versus programming languages that are considered to be functional programming languages. And the nice thing about Python is that it has this very rare niche of actually belonging to both. So it's an object-oriented programming language in the deepest way possible, and it's also a very good programming language for functional programming, which again can be very useful in many times, and we're going to see examples of that playing out. A very crucial factor about Python is the fact that it's very multi-purpose, okay? So across the entire spectrum of programming languages, Python really covers pretty much everything. So you can go all the way from very short scripts, that just do very little data manipulation or organizing some files, very small things that you just need to do something quick and dirty, like in 2 minutes, you can do it. And then all the way through to very large applications. So you can write entire pieces of software, and there have been, in fact, many popular software pieces that were written in Python. For example, YouTube, that we all know and love, it has a very major component within it written in Python. And you can write websites with Python. It has a very nice framework for that. And most importantly for our purpose, it's really the programming language of choice that is becoming increasingly the most popular among researchers. And specifically for biology and bioinformatics, it's really taking over other more traditional programming languages like Perl, R, MATLAB. So Python is really becoming the prominent languages in those areas. Now, another nice thing about a language is that it has a very large and active community of developers. So it's actually very useful to have a programming language that is also popular, because it means it's very rapidly evolving, and you're not in the danger of being left behind. So every time that new methods come out, new pieces of software, you can pretty much count on it that someone will probably give you some interface in Python. So it's very rare that you need to use packages, say, from other languages. So no matter what you need, most of the time you can have all the solutions you need within the Python ecosystem, which is very, very useful. And it's also very useful if you encounter a problem, so you can just search online, and you can pretty much count on it that if you need something, then someone else has already needed it and probably asked the question. So you can already find many questions and answers online of people encountering the exact same problem that you encountered. Or if you have a problem that you don't find a solution for online, you can just ask in some forum. And because it's a very large and active community, people will likely answer to you. It's very important. Okay, so I put for you this Venn diagram, which I think illustrates quite nicely the unique the unique spot that Python is in. So you have languages suited for general applications. So you have languages like Java, C, C++, C#, and then you have languages which are suited for research like R and MATLAB. And the nice thing about Python is, like I said, it's both. It's also great for general applications, it's also great for research. So very useful, and like I said, you can pretty much use the language for everything you need. And there is a very good reason it's becoming the most popular language in really many domains. Okay, some trivia facts about the language, about the programming language. So it was actually named after Monty Python, which you might know, this British comic group from the 70s. And it was created in 1991 by this gentleman named, it was Dutch, Guido van Rossum, that you see here on the right. But actually at the beginning it wasn't very popular. So I think Python became really popular only when Python 2 was released, and it happened in the year of 2000. And actually Python 3 that we now use is with us for over, now it's 12 years, so all the way from 2008. And there's actually been a very long period when, although there was already Python 3, which had already been released for quite some time, people still kept using for quite a long time in Python 2 because there was this transition which was not very trivial for many programmers to do. And only very recently they announced that Python 2 is no longer supported. And I think only now like people are really starting to finalize the transition to Python 3. So as of now, most people use Python 3, but still some people that have some legacy codes, you can still see some applications and pieces of code and packages written in Python 2. But today most people will use Python 3, and that's the version that we're going to use. Okay, so I think that's it for motivation. Let's just, actually start to see how we can work with Python. So let's start with speaking a little bit about the environment that we work with. So are we actually going to make the computer to run the code that we write? So there are many different ways to run Python code. One thing you can do is just to execute py files. So essentially just writing any text file with your Python code and just execute it. That works, but I think it's not the most convenient way to work. So other approaches can be to use a shell. So for example, you can use the standard Python shell that automatically comes installed, or you can use the IPython, which is slightly more sophisticated, and I think in many environments that you download, you will actually get it out of the box. So let's maybe demonstrate it. So I can just execute IPython. You can see I have this shell now opening, and within it I can just start writing code, and every time I hit the enter key, it executes the code. Okay, so I can write some stuff, and Python executes it for me. I can define variables. Okay, and I can then use those variables. Okay, and this allows me very nice and fast and interactive research that I might want to engage with. Okay, so that's IPython. And that's mostly if I want to do something interactive, just to check how some function works, or to see that I know how to execute a piece of code. On top of that, I also have more sophisticated and rich environments. I can have what is known as IDE, which is an acronym, I think, for integrated development environment. So things like IDLE, PyDev, Spider, Commodore, and many others. Just basic interfaces that allow you to create old projects and to manage them. I'm sure that many of you who've worked with programming languages, including Python in the past, have come across those IDEs, which are very useful for people working in team or in large software projects. But actually that's not the solution that I advocate for when doing research. The kind of environment that we're mostly going to work with in this course, and I also encourage you to give it a try in your research, is the Jupyter Notebook environment, which is also known as the IPython notebook. So let's see what it is. So it's actually quite recent. It was originally from 2011. Back then it was called the IPython notebook, and in 2014 it was branched into the Jupyter notebook. So the Jupyter notebook, you can think about it as some kind of an integrated framework that allows you to write code and to execute it, but also add additional kind of components to it. So you can add some text and note and markup within your notebook, and you can add tables and figures and widgets. And in fact, if your own code generates tables and figures, you will see them embedded within your notebook. So you can see, for example, here on the right, a screenshot that you can see how everything is integrated together. So you have those cells of code that you might want to run them, and then you can see those figures are being generated. And you might want to add some title and text and even some mathematical formulas that you want to give some context and explanation to what you're doing. And I think this is very, very nice environment to work with, very suitable for research, because I think it strikes a really nice balance between, on the one hand, being very fast and very interactive, so you don't have any overheads of, trying to organize your code and doing different kinds of organization and maintenance before you actually execute it. You just write the code and you press the enter key and it runs and you get results. But on the other hand, it also gives you a very nice and organized framework for your code. And it makes sure that you have records of everything that you do. So by the end of your research, it doesn't just get lost. Everything that you do is still within this notebook. So you will have all of your codes and all your results and all of your figures, and everything you write, everything will be within it. And I think that the name notebook that they give it is actually very appropriate. You can think about it, it's like a notebook that you can put everything within it, your results and your figures and your text. And you can think about it like some researcher's notebook, that you do some experiment, you see the results, you can then write down some comments in your notebook. And 2 years later, if you remember that sometime in the past you had those ideas or some analysis that you want to revisit, you can just go back to this notebook and everything will be there exactly the way you left it. And very, very good for reproducible research. So I think it's a very nice and suitable kind of environment if we do research. Another nice thing about it is that it always runs within your browser. So you don't need to install any kind of fancy software. You just need to install the very basic Jupyter Notebook, and once it runs in the background, you just open it with your favorite browser. It could be Google Chrome, it can be Firefox, even Internet Explorer if you'd like, and that's it. It just runs, and people mostly use it for Python, but it also supports other languages which can run as different kernels. And like I said, it provides very nice reproducible research. So a very, very recommended environment. So maybe I'll demonstrate quickly. So you can see here I'm within the browser. Now I have Firefox here. And you can see I have Jupyter opened, and I have different notebooks that I can access to. So, yeah, maybe I will open a new notebook and we can demonstrate it. So you can see I just wrote a new notebook, and then I have this new untitled notebook. But I can change its name. I can call it my notebook 2. And then within it, again, I can just write some piece of code and then hit the run button, and you see it executes. And again, I can also write code that extends to more than one line. And again, I hit the run, and you see it's running. And that's code, but I can also create if I want, say, Markdown. So I create some title here, and just some very basic text. So, and I can also incorporate equations. So if I want, I can create some equations. And again, once I hit the run within this Markdown, then it just interprets it as some text. So Markdown is actually very popular in many different frameworks. It's something you sometimes see in forums online. So it has this format, and everything you want, you can just write it down and integrate it very nicely within your code. And very easily you can insert new cells. Each cell can be code or Markdown, and you can just work with it. Yeah. Now, if you want to install this Jupyter notebook, I recommend you to use the Anaconda environment. So you can Google search Anaconda for Python, and you can go to their website and to install it, and just download, install it, and within it you can have all kinds of nice packages, including Jupyter. And if you are having troubles, just do a very quick Google search online. There are many people who have used and installed it in the past. It's not that hard. So you can install it in whatever environment you're used to work with, in whatever operating system. So if you are a Windows guy, you can install it on Windows, or you can install it on Linux. So again, whichever environment is most convenient for you, just install it, and very easy to work with. Okay, so about this specific course, like I said, we recommend to mostly work with Jupyter. You can also work from time to time with IPython. I'm going to illustrate some examples with IPython, but mostly I will use Jupyter, and that's the environment I recommend you to use in this course. It's also everything. We're going to give you all the resources and the solutions to the exercises. Everything we're going to just give you is Jupyter notebooks that you can just download from the model website of the course and just upload it to your local Jupyter environment and just execute it as your own notebook. Okay, so for now we didn't cover that much about all the different nice features that Jupyter and IPython give you. This will come later in the course. I wanted this to be a kind of soft introduction, so not going to burden you too much with too many details, just give you the very basics that you need for now to be able to work with this environment. So for now, we're mostly going to concentrate on the Python language itself. But later in the course, I'm going to show you more nice features and tricks and cool stuff you can do with Jupyter and IPython. Okay, so let's start to actually learn Python. So after the break, in the next part of the TA, we're going to actually go to Jupyter and start to see actual Python syntax and how you can work with the Python. And because we assume that all of you have some experience with programming, if not in Python, then in another programming language, we're going to cover it very, very quickly. So this is going to be a fast crash course for Python, just cover the very basics, assuming that you already know how they work in different programming languages. So we're going to speak about variables and types, about numbers, strings, conditions and loops, and about different data structures.